Introduce themselves. I am going to hit record, and you guys are good.
Okay, well, hello. I am Chloe Romold. This is Max Gillenwater and Josh Martin. And Thomas Bush was also on our team, but he has the flu, so he was lucky he got to skip out. So we did the mowing project. So our task was to figure out how much square footage of this campus we needed to mow. And this did not include all the athletic fields, so the baseball field, the football field, the practice fields behind Young. We didn't count those in. So we used calculus methods that we learned in class, thankfully, before we started this project, to determine how much we needed to mow and, in turn, how much it would cost for us to mow. Our company is Close Cuts Fake Lawn Care. If you grow it, we'll mow it. This is our logo. We will have t-shirts made afterwards. So basically with the four of us and Thomas if he's not sick, we will be all working and we'll have 2 mowers and 2 weed eaters.
All right, thank you, Chloe, for a great introduction. As previously said, my name is Max Gillenwater, and Chloe gave you the task, and I'll be going over the process. Now, the first step we did was we went to Walmart and we bought a yardstick, and we gave it to Josh, and he went out and he measured the surface area of the campus. No. What we did was we got on our school computers and we all downloaded Google Earth. Now what we did was we searched our school and we zoomed in on it so that we could get a good idea of what we were looking at. And if you can see it here, or if you've ever been around the campus, it's kind of weird. There's a lot of curved areas, big open spaces, small spaces you can't really tell. So what we had to do was go through and use the ruler function to cut the property up into measurable spaces, chunks, if you will. Now, if you can see areas like these up here, we split them into trapezoids, squares. Triangles are easy to take the area of. You've got the length times the width, 1/2 length width. You know, other formulas, that's the word. I'm sorry. I'm falling over my own words tonight. Now, there's some other ones that you can't really read quite as well as others. We got random curves, like down here on the baseball field, if y'all can see it well enough. There's the curve right here where we have to measure between this area. We did not do any of the fields. So what we had to do was find a way to measure this curve and all the area here without using a regular equation. Now, Chloe, if you could change slides for me. The only way to do that is with the trapezoid rule, which thankfully we learned in calculus this semester, because if we hadn't learned it, I'd have been lost. What you have to do is you have to find the length of the base of the curve. Now that's your A to B, your delta x, which is your change in distance. And now for a lot of these, it would have been 190 feet or 10 feet. You never knew. But then what you do is you divide that total distance by the number of trapezoids you want to use. Now the reason we're using trapezoids is because if you can see here, they kind of mold to the shape of the curve. If you use something like squares, you'll have a lot of empty spaces that you can't really measure properly, and you're either over or under the total distance. This is still an estimation, but it's much closer than if you use rectangles. Now what you do is you find the height of each side of all of the rectangles by going in and using the, can you go back please? By going in and using the ruler method to go over a certain distance and up to the top. Thank you, go back to it. I'm sorry, I'm all over the place. And what you would do was you would multiply those by the distance x divided by 2 times the number of trapezoids you'd use. The more trapezoids, the more accurate. We usually use 8 or 10. Next slide, please. We usually use 8 or 10, but this example uses 9, which is a weird distance. So you've got the base distance here. If we said it was 100 feet, and if we used 10 trapezoids, we would have divided it by 10. Your distance for each trapezoid base would be 10. You'd measure the first height, and you'd multiply it by 1, and add it to 2 multiplied by the second height. And then you do that for every height until we got to the last one, which we would multiply by 1. We would add all of those together and multiply them by the distance divided by 2 times the number of trapezoids, if that makes any sense. I'm sorry. And then that would be the area of this. Now our next step was to add up all of the areas of the squares, the trapezoids, the rectangles, the weird curve shapes, and we added them up and we got our final results. And I believe Josh Martin is going to go over those with you.
Yes, so as you can see, we have all that math mumbo jumbo. So here at Close Cuts, we take that seriously. So, Young Campus, what are you going to do with all that? Trapezoid rule, that's cool, right? So you got trapezoids. All right, what do you do with it? So you have all of these, this area here. We fill it in, all these weird areas like in the parking lot. I mean, you can't use that with a normal geometric shape accurately. So we used all those rules, broke it up, came up with a number, and we came out with a grand total of 167,193.98 square feet. Now the next example is the auditorium building. We calculated all this area, as you can see from this aerial shot. It is not going to be easy to calculate that with rectangles and squares like we always had learned. So thankfully, due to calculus, which thankfully somebody was awake to pay attention to it, we learned the trapezoid rule to learn how in the world we could calculate all of this and come up together with the area. The area of the auditorium building was 62,167.64 square feet. Now the next one is main campus. It has so much grass in so many weird places. So we did the same rules, principles, they all applied to the same thing. And all of these weird miscellaneous spots scattered out throughout the entire campus, we came up with to a grand total of 340,536.85 square feet. So taking all of this information, we added it all together, which gave us our grand total of what the four of us would have to mow. And that is 569,898.47 square feet. Or in simpler terms, you got 13 acres. So the four of us will be happy to mow 13 acres. And we'll show you how to do it accurately. So go ahead.
Okay. So what we would charge for all 13 acres would be $60 per acre. And this would be $784.80 per every time we mow. Breaking down this cost, we've taken a lot of things like our gallons and our manual labor, because four of us doing all this work, we want some money for it. We're not just going to do it for nothing. So we contacted businesses around the area to figure out how much they charge for each yard that they mow. And most of them used about 2 gallons of gas per regular average yards, which is about 250 square feet. And obviously we have a lot more to mow than they do. So we had to take into account all these things, and we got 16.35 gallons, but that's what it would take for all 13 acres. So with premium gas, it's $2.70 about right now. So the gas would cost about $44 each time we would mow. And we use the premium gas just to take care of our mowers and make sure they don't break down and all that. And then, like I said, all four of us doing this work, that would also add up. And it would take us about 3 hours to do the whole thing, and weed eat. So thank you for listening. We are Close Cuts Fake Lawn Care, and we appreciate your attention, and we hope you will choose us and our expert opinions and knowledge to mow your grass. Any questions?
I have one.
Sure.
How could you make your estimation more accurate using the trapezoidal rule?
Well, that's pretty easy. Since it is an estimation, the only way you could make it more accurate was to add more trapezoids, and therefore, calculating more of the space, which would then increase your accuracy with it.
Anybody else have a question for Close Cuts?
I have a quick question. So you said you had learned this prior to actually doing this project.
Yes.
Well, we actually learned it right before we started doing all the trapezoidal stuff. We'd already done a little bit of it. We had a general idea of what we wanted to do, and then we started learning our trapezoid rule, and we were allowed to apply it before we ever really got started with the complicated calculus part.
So how did learning it or applying it in this fashion shape your learning of the trapezoidal rule?
I think it helped a lot to see it in a real world circumstance. You can see how it actually works out and all the conceptions that go along with it and how you can use it in your daily life, really.
And I can add to that, when I actually taught it, I had to fake draw a pond and do the surface area of a pond because we had to restock it with fish. So this was much better. So. Anybody else? Well, guys, thanks. You'll probably get a call from Mr. Berry about doing this, actually.